Okay, welcome folks. Today we're going to do a little bit of mole practice and some percent comp. Just kind of go over the basics of that for you. Okay, so first things first, when talking about moles in general, we need to review our mole map. Okay, so to review our mole map here, let's start off. Remember, we have the concept of the mole. Okay, now in the mole we can talk about how there are, I don't want that there actually. We can talk about how there are grams, there is volume, and then there are atoms / molecules. Okay, when converting from one to the other, grams to volume, moles to atoms, molecules, we need to follow this roadmap. And basically the key to the roadmap is that everything must go through the mole. So if I start at grams here, I have to convert to moles before I can convert to anything else, whether it be volume or molecules. Okay, so remember, if we're converting from grams to moles, we go to the periodic table. If we are going from moles to atoms, we have 6.02 times 10 to the 23rd. And if we are going from moles to volume, we use the fact that 1 mole equals 22.4 liters at STP. Okay, so let's just go ahead and, using this idea of the mole map here, let's go ahead and solve this first problem. Remember, we use these dimensional analysis is how we solve these. So the question is, how many moles is 2.80 times 10 to the 20 atoms of silicon? Okay, so we're looking for moles, we're given atoms. So that means we start out right down in here, and we just want to go to moles. So this is going to be a simple one-step problem. So we start out with our known, 2.80 times 10 to the 24th atoms. Remember, it is very important to keep our units in check here to know what we're going. Okay, so that's atoms. Alright, so let's remember, okay, we need it to cancel out algebraically, so we need atoms on bottom and mole on top. In 1 mole, there are 6.02 times 10 to the 23rd atoms. Okay, so we just simply plug these into our calculator. Okay, so we've got 2.80 times 10 to the 24th divided by 6.02 times 10 to the 23rd. And that ends up equaling 4.65. We need 3 sig figs, so yeah, 4.65. 4.65 moles, okay, of silicon. Alright, so let's work our next one here. Alright, we need to calculate the number of moles in 75.0 grams of N2O3. Okay, so let's think about our mole map here. Once again, we got mole in the middle, grams, volume, and atoms. Okay, so we're given grams to begin with. So that means we're starting here, and we want to go to moles. Okay, well, if we're doing that, we need to go to the periodic table. Okay, so we need to go to the periodic table, so let's do that. Okay, so we need, what did we need to find again? We needed to find the mass of nitrogen and oxygen. Okay, so nitrogen, oxygen right up here. Nitrogen is 14.01, oxygen 16.00. So let's go ahead and put that in. But first off, okay, what we really need to do is calculate the molar mass of N2O3. So nitrogen was 14.01. There are 2 of them. Oxygen is 16.00, and there are 3 of them, so we add that up. Okay, we need to know how many moles per gram there are. So let's get our calculator out again. Okay, so we have 14.01 times 2, and that obviously equals 28.02. And then 16 times 3. 48. Okay, we add those 2 together. 28.02 equals 76.02. 76.02. Okay, so now that we know the molar mass of N2O3, we can then solve. Okay, so number of moles is 75 grams. So we start off with 75 grams. Okay, now we need to realize that in 1 mole, there are 76.02 grams. So we can run that through our calculator. 75 divided by 76.02, whoops, 76.02 equals 0.9865, so 0.987 if we're using significant digits. 0.987 moles. Okay, that's how we'd solve a problem like that. So let's move on a little bit further now. We need to find the number of molecules in 508 grams of C2H6O. Okay, so for this one here, we need to think about where we are on our mole map. Moles, grams, molecules, and volume. My bad. Okay. So given that, alright, 508 grams. Okay, so we're at grams, we're right here, and we want to go to molecules. So we have to go from grams to moles, moles to molecules. It's going to be a two-step problem. So let's start with what we know. We have 508 grams to start off with. We need to find out the molar mass. So in 1 mole of C2H6O, how many grams do we have? Alright, so we have C, okay, that's 12.01 times 2, plus the hydrogen, which is 1.01 times 6, and an oxygen, which is 16.00. Alright, if we add those all together, so 12.01 times 2 equals plus 6.06 plus 16, that gives us 46.08. 46.08. So in 1 mole of C2H6O, there are 46.08 grams. Okay, now that cancels out the grams, and that got us to moles. We want to go to molecules. So we have to think that in 1 mole, we put the mole on bottom so that it cancels. There are 6.02 times 10 to the 23rd molecules. Okay, so that allows us now to use our calculator. Okay, so we have 508 divided by 46.08 times 6.02 second function to the 23rd, and that equals 6.636. So 6.64 times 10 to the 24th molecules of C2H6O. That'd be how we solve that one problem. There's one other problem to start the chapter 10 that we're going to go over, and that's percent composition. Okay, percent composition. Now when we do percent composition, that is by mass. So to find the percent comp, we take the mass of the element divided by the mass of the compound. Okay, so first thing we need to do really is we need to find the mass of the compound. So we have H, C, and N. Hydrogen is 1.01, carbon is 12.01, and nitrogen is 14.01. Okay, let's just double check that real quick just to make sure. Yep, 14.01. That one always trips me up. So if we add those all together, we get 3. Okay. 17. So 27.03 is what we get. All right, so now we need to find the percent composition. So for the percent of hydrogen, what we do is the mass of the element, 1.01, divided by 27.03. Now remember, this is percent, so obviously we're going to have to take all these times 100 afterwards. So bringing our calculator up now, we'll move that to the side so we can write real easily. We have 1.01 divided by 27.03, and that equals 3.7%. Okay, I already took the decimal and just multiplied by 100 there. If we want to find our percent of carbon, we take that 12.01 divided by 27.03. See what that equals. So 12.01 divided by 27.03, and that equals for us 44.4. Okay, and then finally our percent of nitrogen. We end up with 14.01 divided by 27.03. Let's see what that equals. We have 14.01 divided by 27.03, and that equals 51.8. 51.8%. Now we should be able to add all these up and get dang close to 100%. So 3.7 plus 44.4 plus 51.8 equals 99.9. If you're that close, then you did something right. Okay, so that's basically how we do percent comp and simple mole conversions using dimensional analysis. If you have any questions at any time, feel free to come on in. Have a good one. Bye.